Hey Algebra 2 students, this is Mrs. Bigelow, and I'm teaching a lesson on 8.1, starting on page 430 in your book, called Exploring Exponential Models. So the first definition I want to give you is this, an exponential function. And yes, you will write these three definitions down in your notes. Is a function with the general form y equals a b to the x where x is a real number a cannot be equal to 0, b is greater than 0, and b is not equal to 1. Well, these are the restrictions on this. Okay, that's an exponential function. That's the thing we're going to be doing today, in this chapter actually. Okay, you can use a growth factor. If you take this equation is when b in this equation is greater than 1. A decay factor is when b is between, and b lies between 0 and 1. So an example of this might be 2, 3, 6, 1.8, 2.5, anything greater than 1. An example of this is 1/2, 2/3, 0.75, 0.5, ... Okay? So this is what we're looking at. So we're going to graph this using a table of values. We're going to graph this function y equals 2 to the x. Now you can put it in Desmos, and you will actually put a lot of your homework in Desmos for these exponential functions, but I actually want to show you using the old-fashioned table of values why this looks like it does, and how we get our numbers and all that. So if I were to put a -4 where that x is, you will recall that we never ever want a negative exponent, so we bump it down to the denominator, and this would be 1/16. Okay, everybody get that? Yes, Mrs. Bigelow. Okay, y equals 2 to the -3rd is y over 2 to the 3rd, which is 1/8. And we keep going, and it's 1/4, 1/2, 1, 2, 4, 8. So if we graph this, it's going to look like this. 4 negative 1/16 is way, way small. And then 1/8 is a little bit bigger, but not much. And then we get to a half, and then we get to 1. 1, 2, 2, 4, 4, 8. And your graph basically goes like this. It keeps going and going and going and going. Now, based on my, if you go back up to the growth factor, you see that my b, which is this number right here, is greater than 1. So that means from left to right, this graph should be growing if it's a growth factor, and indeed it is. Okay? So just a few things right here. This line right here, the x-axis, the graph will absolutely positively never cross. It will get really, really, really close, but it will never cross the x-axis. So the x-axis is called an asymptote. In this problem, the asymptote is the x-axis. That means it's a barrier for the graph. The graph never crosses it. Okay, so you're going to do some graphing on Desmos in your homework. I just want you to notice what changes these. Like, say I were to say y equals 2 to the x plus 2. I would hope that you would all realize that that right there is going to bump the whole graph up 2 units. Alright? Just like the same rules we've been dealing with all the other absolute value functions, parabolas, all that stuff. So, anyway, so let's do one more. I think you'll kind of get the idea if I just Alright, so we're going to talk about the growth factor and the decay factor again. If I were to ask you, if I were to ask you what a graph of a growth factor, the general direction, should be something like this, like maybe something like that, right? So it grows from left to right. So this is growth. And this would be decay. So a decay would look like this. Okay, just get to perspective. Remember on y equals ab to the x. If b is greater than 1, we have growth. And if b is less than 1, we have decay. Okay, so let me give you some examples. What about y equals 100? (0.12) to the x. Growth or decay? If you said decay, you get a star. It is decay. And the decay percentage is 88%, or 0.88. Now how did I get that? I took this number in here, and I subtract it from 1. That is how much it has decayed. Okay, that's how much it's decaying with each value of x that goes up. Okay, so let me give you another one. Y equals 0.25 to the x power. Growth or decay? Because 5 is greater than 1, we have a growth, and we have a growth of 400%. How I got that is 5 minus 1 is 400%. So it's increasing 400% with every successive x, right? Y equals 16 times 1/2 x. Growth or decay? half is less than 1. So we have decay, and it's decayed at 50%. That's all I got for you today. The homework for this assignment was homework 88, page 435 to 436. Numbers 1 through 31 odd. Signing out. This is Bigelow.